Hello, I'm Danny McClanahan. This is EmacsConf 2024, and this presentation is ostensibly about Emacs regex compilation, uh, but it'll lean a lot more in future directions. Uh, Thanks for coming on this journey with me. So this presentation is 50 slides, 50 footnotes, and that's intended for it to be a resource later on for your perusal. We are unfortunately not going to be able to go into all of it, but I will try to be within 20 minutes so we can make it throughout Q&A. So this is the structure of the talk. But enough about me. Who are you? And why are you here? So I'm Danny McClanahan. My experience is a lot in build tools, especially, and then package managers. And that started because I realized I was wasting a lot of time. And then I didn't like that. And so I started wasting a lot of time trying to, avoid wasting time. And then I ended up going so far around that I ended up, stopping other people from wasting their own time. In this case, regarding failing builds. But this is a kind of pattern that you'll see. And we'll be talking a lot about patterns in this presentation. So parsing in text is another one of those tendencies that I have. And why am I here? I've got a lot of feelings about text, and for the next 20 minutes, I'm making it your problem. So first off, a huge shout out to Emacs Devel and the Emacs community in general. I spent a lot of time learning about what I'm about to kind of talk about. I was definitely super confused at first. And then when I became less confused and I decided I was going to look at the regular expressions of the regex engine, I was like, oh, it's old C code, it's Emacs. Oh, we can just use modern techniques. And turns out that's wrong for kind of two reasons. One, because these other using modern techniques or other engines don't necessarily do what Emacs regex engine currently does. And then secondarily, that's not actually as interesting as the other kind of larger goals that Emacs Devel discussed. Thank you, Eli Zaretsky, so much, especially and Pipset and everyone else as well. I believe Pipset, I hope I'm pronouncing that correctly. Thank you so much, and I'll be shouting you out later as well. And then these larger goals ended up overlapping a lot with my own research interests, and that's very exciting. So I'm hoping it's exciting for you too. So what is a regular expression? And when and how does implementation match formal theory? So what does formal theory mean? And we'll talk about that. So what is a regular expression? So I might ask you this question, and you might give an answer. And then I might ask someone else, and they might have an answer. And then I might ask myself, and I might try to think of an answer. And our answers would, see, the thing is, they'd all be correct, but they'd probably be slightly different, and they'd be different in kind of important ways. And so I'm using formal theory to kind of describe what unifies these interpretations and what causes this sort of divergence, both over time and then across code bases. So I'm kind of putting a flag in the ground here and saying formal theory is actually a really, really negative influence, I think, but it can be better. And that's what I'm going to talk about in this talk, in this presentation. So we might ask, how did this happen? And we might try to find a start state. And we might put that place at the theories of formal languages that kind of arose, especially post Turing and post Chomsky, and especially there was this really, really interesting and powerful relationship with formal languages between representation and computation. And then on top of that, we have regex as this really powerful union of theory and practice. And then, like I mentioned, this kind of divergence that kind of occurs. And so this divergence, happens for a good reason. This happens because people were adding implementations, and the people people adding features to implementations. And while the people adding these features were often academics, they were industries, people, they were hobbyists, they were interested in building practical tools. This is a good thing. And this is still a good thing, even though it moves a little bit away from formal theory. But we start seeing some cracks developing, and we'll go into that in a second. We're just going to kind of electric slide into the 1980s here, and we're going to be confronted with two occurrences very similarly. We might call it simultaneous discovery. In 1983, you have Michael Jackson demonstrating the moonwalk. 3 years later, we have backtracking developed to simulate egrep-style regular expressions. And these would both be incredibly influential in their own kind of branching paths. So here's where the gloves come off. Formal theory, I claim, remains largely concerned with incremental improvements to artificial benchmarks, and much less with expanding models to cover actual user needs. And this isn't just about, if you listened, to users, that you'd be a nicer person, be a better. And what I'm actually saying is that they're missing out when you don't listen to applications. You miss out on a lot of fantastic opportunities for novel theory. And so this is again my complaint with formal theory as it stands. But we're going to do better. So, but before we get better, we're going to get a little bit worse for a bit. We're going to actually get a little bit worse is better. And what I mean by that is, by the 1990s, we start looking into these non-backtracking engines. And this is a bit of a reaction to backtracking. And the current ones include RE2, Hyperscan, and the Rust regex library. And these are all great. I'll talk about them later as well. And they make use of these. They kind of call back to the earlier formal theory. They have linear runtimes for well-specified search tasks. So what happens if that doesn't fit your needs? We're going to talk about that. So we're going to table that for a second, and we're going to focus more on Emacs. That's the subject of this conference. So what are regex used for? And in this particular case, they're used for lots of things, with practically, and I think they should be. But more specifically, how do Emacs users use them? And I'm going to focus in on this text as input and output, and I'll be kind of elaborating on this analogy as we continue. So why is text powerful? Text as I/O. The reason text programming languages, and not just programming languages, but languages themselves, the reason why they're successful and why they propagate, I claim, is because text is both input, readable, and output, writable. And so what this means is that if you receive something in text, you can read it, and then you can also write it. You can modify it, and you can produce a new version of it, and you're on the same. You're on a kind of level playing field. But that's not always the case, though. You recall that I've worked a lot with build systems and package managers. There's a discussion that goes by the name of software supply chain security. I think it's a massive joke, and the reason why is because people largely raise it to explain why their for-profit company with their for-profit product is going to solve the problem for you, as opposed to the commons of open source. If you are unable to modify or deploy your code without employing an opaque external system, I claim, then you have a hidden dependency, and you don't remove a dependency. You just by for example paying into a for-profit product or using a kind of closed off supply chain, you end up just having a hidden dependency. You end up just displacing that. And so this can actually exert arbitrary control over your programming output and potentially even your thoughts. This is really important. I'm going to dive in a little bit deeper, and I'm going to overload the term locality here. And I'm going to say if you cannot reproduce a system locally, it becomes an opaque external system. And I'm going to give examples here, and these are going to be a bit of a hot take. So first off, GUI IDEs. I think some of us might agree with that here. I say development environments that only allow you to use a graphical interface, do not expose interaction with text, are explicitly trying to kind of place you on a separate kind of plane where you're not an equal contributor to the people who make the development environment, to make the development kind of frameworks here. We'll go one further. Cloud services are precisely they're useful for things that that require large distributed computation. But Twitter, for example, didn't actually ever use any cloud services, external ones, because it was really important for them to actually own their own hardware, their own computation, their own thinking. And cloud services are a way to ensure that you are unable to reproduce a system without paying an amount per month, an amount per day, an amount per second, an amount per cycle to an external entity. And I'm just going to kind of conclude this with, I'd say, the argumentum ad absurdum here, where large language models are all of these at once. They are a cloud service, specifically, and this is what makes them very evil, to make it so that, similar to GUI IDEs, so that text itself loses that ability to be both readable and writable. Instead, text is both unreadable because it's produced by a machine, and then also unwritable because you're subservient and subjugated to the machine, to the large language model, to produce the code in the first place. So you lose this input-output, readable, writable behavior that I claim text has specifically. So to underline this, what is text? Text is local. So finally, we're at the subject of this conference. Emacs, I have double hearts with text. I start off the slide saying Emacs is a text editor. I think that's a good start, and which implements much of its own logic and user interface via text. And so what this means is that, I say without trying. Emacs tries very hard, but without trying so hard, Emacs is imbued with all of the capabilities that text has specifically. And when you use text like Emacs does, and particularly you then start offering mechanisms to query, to transform, and to generally metaprogram text itself, you don't just have the ability to edit code, in new ways. And this is something that I think is often lost, maybe not by participants of this conference, but you particularly start being able to not only just edit code differently, but to change the way that you think about code, and actually to expand your range of thought, the range of actions that you can perform. And you can actually start then editing at the speed of thought. And this is where especially regex kind of comes into play. So finally, we get to the subject or the title of this talk, and I'm about to disappoint a lot of people, and I claim for good reason. Unfortunately, it's a very brief walkthrough, but I'm going to go over what the current Emacs regex engine is, and this is going to give us enough context for the next section on future directions. So quickly, it's a backtracking engine over multi-byte code points. I'll define what that means, and it's in regexemacs.c. It's invoked in two ways, which you'll see is actually the same way over a single contiguous string input. So this is a Lisp string that you pass in, or over the two halves of the gap buffer. So this is when you match against a buffer text. And we'll go into that a little bit more, but this is one of the really actually interesting and specific things about the Emacs regex engine as it stands. So very, very quickly, this is the data layout. This is just, if you're interested, this is where the code lies. So regexemacs.h has RE pattern buffer, which is a struct with actually, I love the Emacs C source code. It's so nice to read. It made all of this so easy. I really appreciated it. So in this particular case, I'm just going to focus on RE pattern buffer actually has the compiled regex. So it's a C struct. It has every single thing that is needed to execute the regular expression against a string input or against a buffer input. And this buffer it's not an Emacs buffer. It refers to just the instruction table and the match loop. And again, this is very, very brief, but I want to specifically focus on the first part. So this is this inner matching loop, and there's a prologue, and then there's a loop body, and there's an epilogue. And the prologue is the really, really interesting part. I say extract current and next car. So what Emacs does here, it doesn't just reach for the next byte. It actually will perform lazily, in some sense, this variable integer size variant decoding for multi-byte. And it'll actually then decode the next 1 to 4 bytes, so up to 32 bits at once, and then it'll actually go into the loop. And so we'll talk about the implications of that later. We next read in the body of the loop, we read the instruction from the instruction pointer, which is again in that buffer field. And then we have this big switch statement, which is actually, love a big switch statement, super easy to read, super easy to understand kind of what's occurring. And then that's the loop body, and then at the end of it, we either increment the instruction pointer if it was matching a single character or something along those lines, or if it was a jump, we don't do that. So a jump, however, though it's not referring to a jump in the sense of a go to, but a jump that's elsewhere within that a table, that buffer field. And if you've concluded a capture, we write that end position there. And of course, well, as you may recall, the 0th capture is of course the entire match string. And so if the capture is 0, then we know we've actually completed that match. And so that's really quick. I would love to receive Q&A about this as well. I've spent a lot of time kind of learning and understanding it. But it's really interesting that this can be described in such a in a single slide because it's really simple. And that simplicity is actually a really powerful thing. And I'll mention that in the next section. And I say, is that all? And I apologize for not doing so, but please ask questions in Q&A or message me about this, because I think it's really, really, again, interesting. And again, I find the code relatively easy to read. And so now here's, I think this is actually the point of the talk. The rest of it was I think just me posturing. This is the really, really interesting part. And this is the ways that we can improve. Well, not just we improve stuff in Emacs, but why those are the right things to improve, and then also how that can be a model for even things outside of Emacs. And so this is going to be a lot of text, and I'm not going to go through all of it. This is the one thing that I tried. This is the thing that I thought would be a slam dunk easy solution. My initial thought process was, well, we tried very hard to do an LRU cache here. It works. It's actually very effective. However, though, we don't actually give the user, the Lisp programmer, the ability to then say, I know that this regex is something that is going to be used again. So I made an artificial benchmark. Because I wanted to show there is one very specific case that it does solve, but it's the same issue with the artificial benchmarks I mentioned earlier. It's very specifically crafted in order to show that this particular solution would produce some speed up. So what this means is it just creates more than 20 regexes in a row. It compiles them, and then of course, because we just don't pay the compile costs, but because we don't go through that cache eviction process, it ends up being faster. But that doesn't really mean very much. Particularly the goal here, the goal would have been to show that the compile cache is actually causing a performance issue in comparison to pre-compiling it, and that's not something I've been able to show. And so match over bytes, not cars. So this is when I said at the beginning, I came in and I think, we can just use modern regex engine techniques. This is really what I meant. And in particular, I mentioned in this match loop here that there's this prologue that does this variant decoding. And what this means is that every single iteration of that loop is going to be interspersed with this not being able to read a fixed number of bytes, but a variable number of bytes, just depending upon the Unicode character or the Unicode code point or the multi-byte code point. So this ends up again being relatively difficult to optimize because processors operate over bytes and not over code points. Yes, we might have we could consider a multi-byte CPU at some point, but this is a really, really simple thing. It's just generating automata that operate over bytes as opposed to code points. This kind of goes into the much more abstract one, and there's a lot of text here, and we're not going to go into it. But the really, really important point that I'm specifically mentioning here is this explicit control over linguistic complexity, and that's like that's the abstract kind of point. So I want to propose or introduce the inputs and the outputs, and basically when you perform a search or a match or parse, those are different tasks, and they'll have different expected inputs and different desired outputs. And so right now, Emacs, the API for the regular expression engine and for matching, it doesn't allow specialization on this. Or rather, if we do specialize on particular inputs, if we have a heuristic to check if a regex is actually a literal string, that's not something that the user actually has control over. So for example, you can make a mistake escaping something, and then you don't have a literal, and then you accidentally have behavior that you totally didn't expect, not just correctness issues, but also performance issues. So I really like this one. I like this a lot because I didn't think of it at all. Um, and I think it's better than all of my ideas. This was proposed at least to me by Pipset, and I really hope that I'm pronouncing your name correctly. I'm sorry I didn't ask you beforehand. On Emacs Devel, in particular, this was after a couple of responses where I was trying to say, oh, I want to give the Lisp programmer way back, in here. I want to give the Lisp programmer, control, the ability to control compilation in some sense, but he mentioned, I think he is correct, the, there's no real introspection, and that happens because it's written in C. And so I was thinking, oh, if I turn this into a Lisp object, that gives the Lisp programmer the power and the ability to do more with that. But it doesn't actually, because it's still in C. And at first I was thinking, oh, we can make the C part more flexible, but actually, especially if we want to do almost any of the things we previously mentioned, I think basically that this is like I think that if I'm not going to do it, somebody else really should do it, and I think we should maybe even do it together, because I think this is really, I think, how we can start experimenting, and not just experimenting, but because, as mentioned here, we have libgccjit, we have the native compiler, we have the ability to specifically to generate specific code for this. So why not implement the or a regex engine itself in Lisp? And this gives us the ability to introspect it. That's one of the things I mentioned at the beginning. But it actually gives us the ability to then actually look at all the previous implementations, to explicitly compile beforehand, to match against bytes, to specialize and dispatch based upon input and output. And this is something that it's super simple. It's really smart, and I'm really glad Pip mentioned this, because it is, I think, the right way to solve the rest of it. So we're at the final section, and I've talked a lot about kind of abstract thoughts, and I talked a little about specific solutions, but I especially talked about what is regex in Emacs, and I don't know if I had a lot of specific examples of it, so I'm going to just describe kind of my I guess motivation, my impetus, and then I think something that's really something to chew on for the future. So, do I have any concrete examples? Yes. Well, you can decide if they're concrete. Or am I just posturing? Also, yes. Helm RG, Helm erg. It's literally just MX grep, but it uses rip grep, which is written by the same author of the Rust regex tree. So it happens to be very fast. In particular, I use this tool with rip grep on the Twitter monorepo, and I was able to search very large amounts of code that was on my local machine using regular expressions. And I think this is one thing that I think is really important, because when you want to scale, there's people say the word scaling, and they assume there's a specific kind of answer for that. And I've just found that text is not only flexible, it's actually something that can be more performant than the alternative, and not only more performant, but more productive. So it's just MX grep using rip grep. There's a tool, dead grep, by Wilfred Hughes, which is also fantastic. I think it's actually better than this, but this one's mine, so I can mess around with it. But this tool is kind of why, especially, I started looking into Emacs and looking into changing the way that, or at least diving into how the regular expression matching actually kinds of works, both in Emacs and then in rip grep. And so we'll go to the next one. So this is something that does exist and continues to exist. This is something that doesn't quite exist yet. So I'm calling it telepathygrams. It's it's the name, and it's very it doesn't work, but it's a code search tool that, in this case, precompiles the database to execute NFAs against. So I was thinking, how can I beat rip grep? And the first thing I thought is, well, as I have worked on build tools, and especially in monorepos, one of the things that the pants build tool from Twitter does is it uses a file watcher to ensure that instead of having to constantly read in the entire contents of a file, which may be very large, it only does so when the file's been changed. So finally, I want to conclude on this note, which is just that the stuff I didn't learn from Emacs Devel, I learned from Paul Wincadia, or Junior, who is the RE2 maintainer, and he taught me quite a lot from 2023 to 2024. And I'm thankful for the time that I learned from you. So thank you, Paul. With that, we're at Point Max. Call me, beat me if you want to reach me and or hire me. These are places that you can reach me at. There are probably others. feel free to suggest other ways to contact me. But for now, this is the end. So thank you so much for the time. I really appreciate it.